Alright, hello everyone. Since we will miss out on our 12 method lesson tomorrow, so I just record this video to catch up for 4E and 4F, which are about cubic functions and quartic functions. Alright, so before we do 4E, I want to just re-mention about the sum and difference of cube. These two equations, I already wrote them onto our whiteboard that day on Friday. But I just want to re-mention here. If we have a plus b to the power of 3, that will give us a to the power of 3 plus 3 times a to the power of 2 times b, and plus 3 times a times b to the power of 2 plus b to the power of 3. And what is in your textbook is these two formula over here. So we have a to the power of 3 plus b to the power of 3. You can factorize them into a plus b, the sum, times a to the power of 2 minus ab plus b to the power of 2. And a to the power of 3 minus b to the power of 3 can give us the factorized into a minus b times a to the power of 2 plus ab plus b squared. And how do we use such a formula? Is firstly, the question might give you 64 minus a to the power of 3, and they ask you to factorize it. And you can directly apply this formula over here. So you can say, okay, 64 is equal to 4 to the power of 3. A to the power of 3 is just basically a to the power of 3. So now you can write the equation equal to 4 to the power of 3 minus a to the power of 3, which give you 4 minus a, because you have a minus b here, and then times 4 squared plus 4 times a plus a squared. That's your first question. Okay, and we follow the same process for the second one. A times x to the power of 3 plus 125. We simplify it first. Remember, we want to have this whole thing to the power of 3. So that gives me 2x bracket to the power of 3 plus 5 to the power of 3. And then we can use the first formula over here. That will give us 2x plus 5 times 2x, remember the whole thing squared, minus 2x times 5 plus 5 squared. So in the end, you should get 2x plus 5 times 4x squared minus 10x plus 25. So that's how we do for the second one. And the last one, we also still using the difference of cube formula. We put this into a whole thing cube first. So 216a cubed equal to 6 times of a, the whole thing cubed, right? So now our function came into 6a cubed minus b cubed, which give us, using the second formula, 6a minus b times 6a squared plus 6a times b plus b squared. And then we simplify this, give us 6a minus b times 36a squared plus 6ab plus b squared. Right, so this part is just for the sum and difference of cube. If you find this one still struggling, please email me and I will send some other question for you to do a practice. Okay, the next part is for our rational root theorem. First case is, when do we really use this theorem? If we try to use the factor theory first, and we try those integer numbers. Remember in class we mentioned that if p alpha equal to 0, that means x minus alpha is a factor of px, right, of the polynomial. So if you try different integer numbers, that all doesn't work. So now you would try a fractional answer. That is when we moving from x minus alpha into beta x plus alpha. Okay, and how do we use it? So the rational root theory is for polynomials if it has the leading term a to the an times x to the power of n plus an minus 1 x to the power of n minus 1. So this is just the equation of the px, it's the polynomial. if it has a factor of beta x plus alpha, okay, if beta x plus alpha is a factor of this polynomial, then this term beta is a factor of the leading term. So that means beta is a factor of an. For alpha over here, for this alpha is to be the factor of our constant term. So that means alpha need to be a factor of the last term. So alpha is over here. And in this case, when we say alpha and beta, they should have the highest common factor of 1. So that means it's the simplest. So you can't further simplify the fraction anymore. So alpha and beta, you can't be like 2 and 4, which can be further simplified into 1 and 2. So these two should have the highest common factor of 1 already. And now, if beta x plus alpha is a factor of it, and we say the p negative alpha minus beta, it will equal to 0. So this is using the factor theory idea again. So using the remainder theory as well. If p negative alpha over beta equal to 0, then our beta x plus alpha is a factor of our polynomial. Okay, so this is our rational root theory. But the thing is, how do we use it? So let's see some example. The example here, we need to factorize 2x cubed minus x squared minus x minus 3. And remember last Friday, we learned how do we factorize it? We firstly try different factor numbers. So when we try it, we use the factor of our constant number. Okay, that's where we start. And our constant number here is negative 3. So the factor of negative 3 might have negative or positive 1 or negative or positive 3. There are 4 factors of negative 3, right? And then we try substitute these numbers inside. P1, P negative 1, P3, and P negative 3. Okay, so you solve these values into x. And if you solve them inside, you will realize none of them equal to 0. Okay, so none of them equal to 0. So that means there's no integer factor, or say no integer root of this polynomial. So this is the case where we need to use our rational root theory. Integer doesn't work, then we try fractions. Okay. So now we use our fractions. And where do we get this number like the fraction from? We're using our beta x plus alpha. So if beta x plus alpha is a factor, beta would be a factor of the leading term. Our leading term here is 2. That means beta could be positive or negative 1 or positive or negative 2. So that's our value for beta. And alpha would be a factor of the last term, that is negative 3. So alpha could be plus or negative 1 or plus or negative 3. Right, so now we have our beta and alpha ready. And what we need to do is we need to writing out the beta plus alpha. There are different combinations. Okay, so combinations. So what can we have for beta x plus alpha? We could have 1x plus 1. We could have 1x minus 1. 1x plus 3. 1x minus 3. Or we could have negative x plus 1, negative x minus 1, negative x plus 3, negative x minus 3. Or we can have 2x minus 3, negative 2x minus 3, 2x plus 3, negative 2x minus 3, 2x plus 1, 2x minus 1, negative 2x plus 1, negative 2x minus 1. So we have different combinations. Alright, so if you try to write down the beta x plus alpha, that give you all the combination here. And this is a little bit time consuming. So the quicker way is you directly writing out what is p negative alpha minus beta. So you're just looking for what would be the possible combination of negative alpha minus beta. For our negative alpha minus beta here, that would give us less choices because we could have negative 1 over 1, negative 1 over negative 1, negative negative 1 over negative 1, or negative negative 1 over 1. This will give us only two choices, isn't it? So this will give us only negative 1, positive 1, negative 1, and a positive 1. So we can get rid of these two. And similarly, we can have negative 1 over 2, negative 1 over 2, negative 1 over negative 2, negative 1 over negative 2. And that will give only negative half or positive half. And similarly, we try for 1 and 3, that will give us either negative 1, negative 3, or positive 3, or negative 3 over 2, or positive 3 over 2. Right, so in the end, I will only have these choices over here. And because we already tried the integers numbers, 1 and 3, they are crossed out. That gives us only 4 choices here. So we solve them inside of the polynomial, which give us negative half, p half, p negative 3 on over 2, p 3 over 2. Right? Okay, so now we just solve them inside. You will find this one not 0, not 0, not 0, but p of 3 over 2 equal to 0. So if 3 over 2 equal to 0, that means negative alpha minus beta equal to 0. That means 3x minus 2 is a factor. Alright, so that would give you 2x minus 3. So alpha is the behind one. So 2x minus 3 is a factor of this polynomial. You can also write it as negative 2x plus 3. It's the same thing. So now you have 2x minus 3 as one factor. So you can do the long division or using your calculator. So now your px equal to negative 2x plus 3 times another quotient qx. Okay, and if we're using our long division, we will get 2x cubed minus x squared minus x minus 3 divided by negative 2x plus 3. And we just using the long division method we did on Friday. That give me negative x squared. That's 2x cubed minus 3x squared. And negative x squared minus negative 3x squared. That will give me 2x squared minus x minus 3 So 2x squared divided by negative 2x, that's negative x. So that would give me 2x squared, and then negative 3x, and negative x minus negative 3x. So that would be 2x minus 3, and that gives me negative 1. So that would be 2x minus 3, give me 0. So now my polynomial function is factorized into negative 2x plus 3 times negative x squared minus x minus 1. Okay, so one thing I want to mention is, if you here, you have your negative alpha over beta equal to 3 over 2, what is 3 over 2? So that means negative alpha divided by beta equal to 3 over 2. You can say alpha equal to 3, beta is the negative 1. Or you can say alpha equal to the negative 1, beta is the positive 1. So it's your choice. It's fine for both ways. Okay, so that's the example for factorizing 2x cubed minus x squared minus x minus 3. And I will do another example over here. So we have 3x cubed minus 5x squared plus 4x plus 2. So same thing. First we try factorization, factor theorem. And when we try factor theory, we firstly try the factor of the constant number. That gives us positive negative 1, positive negative 2. So P1, P negative 1, P2, P negative 2, and P1 give you 4, P negative 1 give you 10, P2 give you 14, P negative give you 50. None of them equal to 0, so there's no integer root. That's it when we need to use our rational factor theory. And how do we use it? So we have beta x plus alpha. Beta is the factor of leading term. That is 3. So beta could be positive negative 1, positive negative 3. And alpha is the factor of last term. That gives you positive 2. So your beta alpha could be plus or negative 1, plus or negative 2. And now we just try different combinations. So you're trying to have negative alpha over beta, and you're making it into 0, right? So what could be our negative alpha over beta? It could be negative 1 over 1, negative 1 over negative 1, negative 1 over 1, and these are going to be the same. So for 1 and 1 combination, we will just get either it's negative 1 or positive 1. And then we have negative 1 over 3 or positive 1 over 3, because you try this pair over here. So you would have negative 1 over 3, negative 1 over 3, negative 1 over negative 3, and negative 1 over negative 3. And that is just repeatedly giving you either negative or positive 1 over 3. So you would have 1 over 3 or negative 1 over 3. And same thing, you would have positive or negative 2, or positive 2 over 3, or negative 2 over 3, right? And for the integer one, we already tried the 1, 1, negative 1, 2, negative 2, so we cross them out. That gives us 4 trials that we can keep on. So now we have negative 1/3, negative 2/3, or positive 2/3. Okay, so what we do is just solve them inside. What is P 1/3? What's P negative 1/3? What's P negative 2/3? And what's P 2/3? And if you just try to solve them inside, you get it's not 0. This is not 0. This is not 0. But negative 1/3 solved inside the polynomial will give you the answer of 0 in the end. So that means your negative alpha over beta would equal to negative 1/3. That means your alpha would equal to 1, beta equal to 3. Okay, this is the simplest combination. You can do negative alpha equal to negative 1, beta equal to negative 3, but that's not really necessary. So you just use the positive ones. That would make your calculation much easier. So now you have alpha equal to 1, beta equal to 3. Therefore, 3x plus 1 is a factor of the equation. Okay, and then you continue using the long division method that we did in class. I'm not going to completely doing that. So you will have in the end is px equal to 3x plus 1 times x squared minus 2x plus 2. Okay, and that's for our rational root theory. So to summary up for our 4D section, is over here. When we try to factorize a polynomial with a degree higher than 2, we do the following. We use the factor theory to find the factor. First, try to find the integer using the factor of the constant number. If the integer doesn't work, you try the rational root theory, the beta x plus alpha, and you try p of negative alpha over beta until it equal to 0, and then you find what is the factor of the polynomial. Once you find one factor of the polynomial, you divide the polynomial by this factor to reduce the degree, and until you factorize all of them. Alright, so that's for our 4D part. If you still have any question or any confusion, please email me or talk to me on Tuesday lesson, and I'm really happy to help.